Exercise 5, CREO Parametric 2.0. In this exercise, we take a look at CREO's capabilities when importing objects using the bottom-up method of assembly construction. Bottom-up method typically indicates that the parts are already pre-made and you just drag them into an assembly and you attach them using constraints and via surfaces and axes and things. So we're going to go ahead and construct this assembly that you see right here on the screen. It consists of mainly a series of parts as well as a subassembly for the crank at the top. So let's begin. Let's first start off with the new by going to File, New, Assembly, and let's go ahead and call it capital E5. If it doesn't accept E5 because there might be an older version you might have on your computer, just type in E5, B, or C, or D. Hit OK. Alright, with an assembly, assemblies typically look and act or behave just like a part file when you first look at them. In fact, if you want, you can turn on the tree filters by clicking on the little hammer there. Go to Tree Filters and just click on Features there and hit OK. And now you can see the assembly has its own right, front, and top plane. It has its own coordinate system. You can turn those on if you want to see those. We'll leave them on just for a few minutes here while we actually bring in the first part. Then we'll go ahead and hide them. Now right now I'm in an isometric view. If you're not in an isometric view, you have the ability to go ahead here and just go to default or standard orientation. Isometric or trimetric is good. We'll begin by first inserting a part. Now up here you have two methods. You have create, which is more the top-down method. You could construct parts inside the assembly and base them off of geometry that either skeleton assemblies and things like that off of sketches that exist already. In this case, we want to go to Assemble, and you'll see there's Assemble, Include, Package, Flexible. We want just Assemble. Okay, hopefully you're defaulting to your Exercise 5 Pro. Beware, you could go to Vertanux, VERTANUX1, that's the number 1.com, and download these files, as well as there's a training manual on there as well, under the CREO 2.0 Basics. Anyhow, the files are there if you want to grab them. In this case, I'm looking for a part, and it's going to be called the sheet metal bracket. In this case, actually, I just called it bracket, but in the parts you have, it's probably called sheet metal bracket, so just be aware of that. Okay, here we can see we can position this. You actually have this nice tool here for actually locating how you'd like it positioned. If you want to manually position it. Otherwise, you could go up here where we have automatic, hit the little arrow to the right of that, and there's a series of options. We actually want to go with default in this case. Go with default. That will automatically lock the part in to where the part's origin is assigned to the origin of the assembly. This is a very nice feature. For example, if you're doing work for a larger company that builds everything top down, many times they have a centralized origin for all the parts. Therefore, you could actually insert the parts individually if you wanted to, and they should assemble themselves in the positions they were created in the other system. It doesn't work all the time though, so be aware that sometimes if the origins aren't all centralized, then you have to do it manually, which I'll show you in a minute. So once we get that to default, just hit the green check mark. I'm going to go ahead and turn off some of these objects here. And now I'm going to go to Assemble again. And this time I want to find the yoke male and hit open. Okay, and again, you could position this and relocate it just by grabbing the drag handles on there. But what we're really looking to do is we want this cylindrical face to contact this cylindrical face in here and be aligned. So you can actually go to placement. If you go to the placement button, you don't necessarily need to go to the placement, but there's an option here that I want to show you that will allow it to move freely, and we could apply what's called dynamic assembly motion to this. But for the selection here, I'm going to click in this box right here. I want to select the cylindrical face. Now be careful if you have it rotated in any way. There's actually a flat face on the other side. We don't want that just yet. Select the cylindrical face. And then move your pointer over here and find the cylindrical face inside the hole here on the sheet metal bracket. And it should align itself. Now, if you grab the little arrows here, you can see you could drag it up and down, but the other arrows are grayed out. It has lost the ability or those degrees of freedom to move in those positions. Anywhere where you see a color, though, you do have the ability to maneuver it. So here you can see if you grab that green ring, it turns blue, select it. You could rotate it around. All right, we're going to go over here to New Constraint and just make sure that it's maybe dragged down a bit so you can see this top surface here that I'm about to select. We want that surface to contact the underside surface here. So we might have to actually hold down middle mouse button down on our, or actually the scroll. If you're not aware, you can push down the scroll and move your pointer up, and it should rotate so you can see the underside. Now you can select that little face up there at the top of the bracket, and it should align itself coincident. Now, there's a checkbox here, Allow Assumptions. If you fail to select or unselect this checkbox, you'll have to go back later on to uncheck all of them on the features because it starts to add them by default. By selecting it the first time, usually it defaults to being off, therefore. And if you have Allow Assumptions on, you cannot apply the dynamic assembly motion. You have to turn these little checkboxes off. But you could always go back and edit the feature on the tree and do it. But just make sure you turn off Allow Assumptions in here, because we do want some free range of movement here. Go ahead and hit the green check mark. Now, just to test what we have here, let's rotate it around a little bit. If you go to Drag Component, the little hand here, you should be able to click anywhere on the part, this yoke mail, and now rotate it, and you'll see it will spin around. So it's lost some of its degrees of freedom, but not all of them. You could completely lock it down if you wanted to with maybe a plane, make the plane parallel to this face or whatever, but we actually want to leave some of the degrees of freedom open so we could rotate it in this specific case. Go ahead and hit close here. All right, as far as the next item here, we're going to go ahead and import another part. So we go to Assemble and find the spider hinge. Hit open, and again you can see this component. You can move it around, up and down. If you grab these rings, you can actually rotate it if you wanted to. Sometimes it's helpful to get it closer to the position it's going to be mounted ahead of time than later. Anyhow, now I'm going to go ahead and go to Placement and click in this little box here. And what we want to do is position one of the holes here. See that cylindrical face? Select that. To this blue hole here, the blue surface. Then select that. Then hit New Constraint. And I'll select this flat face here. You could do it to the other side too if you wanted to, but just make sure you align it to the blue face over here. Now you have the ability to flip it sometimes. It doesn't depend upon the constraints. It might actually give you strange meshes sometimes, but needless to say, in this case it went improperly, so we don't have to do that. Notice Allow Assumptions is unchecked by default. If you, again, first time if you fail to uncheck it, unfortunately it's going to keep adding it by default, and that will prevent us from moving it. I'm going to hit the green check mark. Now let's see what we can do here if we go to Drag Component. We could click on this part and move it around, and you'll see everything could spin pretty easily. Now you'll notice on the other side of this spider, there's 4 little holes. Make sure that those are pointing down, just like that. Now let's go ahead and introduce another part. Go back up to Assemble, and I want you to find the yoke female this time. And hit Open, zoom out, and we can maneuver this closer into a position that's worthy. Okay, and now from here go to Placement again. Click in that box. You could select any of these holes here to the blue hole. Okay, hit New Constraint. Select the red face now, and select one of the inside faces of the leg that it's going to align to on the yoke female. There we have it. Now it's not quite done yet, but let's say by accident you hit enter or the green check mark. And then you realize, oh, we never mounted it down to this bottom surface here yet. Anytime you have to edit something inside CREO, this is all you do. You find the feature in the tree. Remember, these don't always show up. Remember, the little hammer tree filter, you might have to turn on the features to see them. But anyway, you just right-click, in this case on yoke female, and we want to go and edit the definition. This will bring us back to our placement options, and we could add a new constraint. Now in this case, we're going to go ahead and select this flat underside face, this part, and then rotate this around until you see that pale green face on the inside of this bent flange. Go ahead and click on it. Now you might not see anything happen here. That's because the constraint type might have defaulted to something that's not valid for this surface. Offset angle, not going to work. Instead, try parallel. And then hit, let's see if we hit flip here. Okay, we're not getting it to go. What I'm going to do is I'm actually going to right click and I'm going to delete that. And let's go, we'll start off with parallel and see if we can get that in there. In fact, actually, I think I'm going to go ahead and, apparently I deleted the wrong, darn it, let me delete that. Okay, we've lost one of our constraints here. I'm going to have to re-add it. So new constraint, this face to this face. Okay, I'm going to hit apply, and this time I'm actually going to go drive component. Let's just make sure that this can move. Now, if we're having difficulty, remember, you just click on it and try to line it to that face as close as possible. Sometimes if it's lined too far beyond the limit, CREO has a difficult time attaching those two. So get it kind of close. Remember, that's just with this drag component. You could click on it and move it. Now let's try that again. Right click on yoke female, edit definition, select, actually go to placement, and let's make sure we go with parallel. The reason why we're going with parallel is you might not realize this, but there's a short distance between those two. Coincident, if we were to default to that, would want to make face-to-face contact, which we can't have. There we go. Now in this case, it did go with coincident, interestingly enough. Let's just make sure that it seems to have overridden one of our entities here. It's okay. Let's see if we could add that. There we go. And let's hit the green check mark. Let's test this out. Now to test it out, go to the drag component. Okay, and it couldn't be satisfied, and that's because apparently I have something that it doesn't like. So let's try that again. And I have a feeling I know what it is. I'm going to right click and I'm going to edit the definition again. For some reason, the parallel option still shows up between these two entities. I'm going to delete this. And then the last coincident here, at the base, actually does need to be parallel. I think that's what's causing us some trouble. Let's try that. Okay, go to drag component. And now if we click at the top here, we should be able to see our dynamic assembly motion. My apologies if I messed you up a little bit there. Anyhow, so there we go. Hit close. Alright, the next item of business here is we need to go ahead and add some pins. So I'm going to go back to assemble, and I'm going to find the blue pin. We're going to need 2 of these, but we'll just bring one in right now. Drag that up there. Now what I could do, instead of going to placement every time, I could just select the cylindrical face here and find the blue hole, blue cylindrical face on the leg of the yoke. Align that and hit apply. Actually, now we don't hit apply yet. The next thing we want to do is I'm going to go to placement now, go to new constraint. I want to add a distance. And the distance is going to be between this face and this face here. If we move this closer to it, we can actually get feedback on how far we're moving it. And we actually want it to be somewhat flush to the surface there. And honestly, that 0.06 doesn't look too bad. That's the distance between this blue face and the end of the pin. And I think I'm going to keep it at 0.06 and hit the green check. Actually, don't have to hit the green check. Oh no, we're ready. Go ahead and hit the green check. Okay, now we're going to go ahead and add another one. So go to Assemble, blue pin, and do the same thing. Select the cylindrical face of the pin and the blue hole up here. Now select this end face here to the blue flat face that's here. And we can just type in, by double clicking on this dimension, 0.06, and it should go flush. And hit the green check mark. Alright, now we need to bring in a red pin. So go to Assemble, find the red pin, hit Open. And now the red pin is going to be aligned from the cylindrical face here to the red hole. And then the same technique, click on this end face to this red face, flat red face. And let's drag it, grab it, and drag it in. Actually, let's grab the dot there. And again, it should default to 0.06. If it doesn't, you can go ahead and type it in manually. I believe actually 0.065 bring it in a little better actually, so it's nearly equal on both sides. Go ahead and hit the green check mark. Alright, now there are some little set screws that we could put inside here. I'm just going to put one in and you could practice with the rest. Now the set screws, let's see. Look at the preview here. Oh, it's under fastener. It's called fastener. Hit Open and select the cylindrical face to one of the holes here. I'll select this hole here. And we can see the set screw here. And then select the end face to this face here. And what we're going to do, instead of a distance, notice it defaults to distance, set it to coincident. That makes it flush with the end. And there's our set screw already inserted. Now you could add the others if you like, the same method. It's good practice. I'm just going to leave it at the one. Now finally, we want to add a subassembly to this. Subassemblies work the same way as a part file. You just go to Assemble, and in this case you're going to find the handle subassembly. So it's actually handle sub. Hit Open, and we're going to first relocate this. I want to drag the green handle up, give it some good distance away, and we're going to allow these to be concentric. So this pink face right here, concentric to this pink face here. Now also, we're going to go ahead and select this flat face over here and mate that to the flat that's over here. Okay. And in this case, I got an angle. So instead of angle, I want to go with parallel. And finally, select this end bottom face to this top face of the bracket and set the distance, and we're going to set it to 0.0393, which is 1 millimeter in inches, and hit apply. And so you'll see a little distance gap between it. Okay, and now the test here, if we rotate this around, we go to drag component and click on the handle and rotate it around, and everything should move together. That's dynamic assembly motion. There it is. And that concludes exercise 5.